All right, this is Geometry A, Unit 4, Lesson 7. We're going to examine rotations a little bit more. I actually presented some of this unit in the last video. We were talking about rotation mappings, introducing or reintroducing the concept of a transformation mapping. Basically this format where x, y becomes, and is expressed with an arrow, as something else, some transformation on x and y, some function rule based on x and y. In this case, we defined a 90-degree rotation by experimentation as switching the x and the y. Notice y comes first, x comes second, and changing the sign on the y so that a 90-degree rotation turns out to be xy becomes negative yx. A negative 90-degree rotation, and let me define these terms, these rotations. A 90-degree rotation is a rotation starting from the positive x-axis going 90 degrees. So this is 90 degrees. Spin at a quarter turn, a quarter revolution in the counterclockwise direction. Positive rotations are counterclockwise. Okay? You may refer if you're into auto mechanics, righty-tighty, lefty-loosey, right? Righty-tighty is actually the negative direction in mathematics. That's clockwise. Lefty-loosey is the counterclockwise direction, is the positive rotation angle. So negative 90 means start with the x-axis in the positive and then rotate it clockwise, negative 90 degrees. Okay, and then 180, and you'll notice I have indicated 180, by the way, is the same as negative 180. They end up in the same place. 180, negative 180. So I haven't specified a separate rule for negative 180. They're the same rule. I also haven't specified a rule for negative 270 and positive 270 because if I take a positive 90-degree rotation, that's the same as a negative 270-degree rotation. And likewise, a negative 90-degree rotation, a clockwise 90-degree rotation, negative 90, is the same as a positive 270-degree rotation. 270 degrees being 3/4 of 360, a full of 3/4 of a full rotation. Okay. So that's kind of the way that works. And let me demonstrate this using just a set of points. Let's say that x and y, let's let x equal 3 and y equal 1. Okay, in that case, the point 3, 1 represents the original, right? 3, 1. Let's follow this rule. So 3, 1 is going to become, switch the terms and negate the y. So negative 1, comma 3. Negative 1, comma 3 corresponds with a negative 90 degree, or positive 90 degree rotation, counterclockwise. Okay? Negative 1, 3. Whereas if I start with 3, 1 here and switch and negate the x, so y and then negative x, negative 3, we get 1, negative 3. That goes down here. That corresponds to a negative 90 degree rotation, or a clockwise 90 degree rotation. Negative 1, 3. Okay? And if I start with 3, 1, you'll notice we don't switch for a 180 degree rotation. That's because you can think of it as two 90 degree rotations. If you switch and change the y, and then switch again and change the x, you've changed both signs, but you've switched the order back, right? And think about that for a little bit and play with it, and it'll make sense. So for a 180 degree rotation, or we call it an origin point reflection as well, you just switch the x, or don't switch the x and the y, you just switch the signs on x and y. So 3, 1 becomes negative 3, negative 1. Negative 3, negative 1. And that corresponds to a 180 degree rotation. Okay, negative 3, negative 1. All right, so hopefully that makes sense. I'm going to pull up Desmos, and we're going to play with this a little bit. Okay, I've got in Desmos, and you can create this using a table. I've created a table, and just hit plus and then choose table. I've created a table with the following points: -2, 1, 4, 0, 3, 4, and then I list -2, 1 again. And I click and hold on the green. I'll try that again. Click and hold on the green, and I've turned lines on so that it draws a triangle. Okay, and we're going to apply these rules. Okay, so I'm going to go to line 2 here. I'm going to get plus and table, and I'm going to apply the 90-degree rotation rule, which says take X and Y and switch, right? And change the Y into a negative. Got to think about that a little bit. Or change the X into a negative. Or what was the Y into a negative. Okay? So we're going to switch. We're going to put 1, 2. Changing the X. -2, 1. That's going to be a counterclockwise rotation. Or a clockwise rotation. So we need to do it the other way. So 1, -1, change the Y, -2, there we go. Switch the X and the Y, change the Y to a negative. All right, 4, 0 becomes, the negative of 0 is 0, 4. Switch the 3 and the 4 becomes -4, 3. And then switch the -2 and the 1, so the 1 comes first, but change the -1 to a -1, -2. Okay, and let me turn on line drawing here and see if we've got it. Okay, and it makes the same triangle. You can kind of picture it. It turns 90 degrees, right? All right, so switch the X and the Y, change the sign on the Y. All right, that's a 90-degree rotation. Let's go ahead and get rid of these. And let's do the clockwise rotation, or the negative 90-degree rotation. So this, we switch the X and the Y, and we change the X sign on the X. So -2 switches to Y and becomes +2. The 1 just switches. Okay, the 4 switches to Y and becomes -4. The 0 just switches. The 3 switches to Y and becomes -3. The 4 just switches. The -2 switches and becomes +2, and the 1 just switches. Okay, there we go. There's our 90-degree rotation, right? 90-degree rotation. All right, and let's do a 180-degree rotation. Okay, rotation for 180-degree rotation, either positive or negative, the result is the same. Just change the signs. So -2 becomes 2, 1 becomes -1. Okay, 4 becomes -4. Actually, let's just use this. -4. 0 becomes 0 because 0 is its own negative. -3, -4. +2, -1. There we go. We've got a 180-degree rotation. All right, so hopefully that makes sense. It's kind of fun to start with the rule, apply the rule, and then see that it results in a rotation like we anticipated, rather than start with the rotation and try to anticipate or calculate or figure out the rule.